In this video, we're going to look at how to graph a rational function and check horizontal and oblique asymptotes. And as always, I've got a TI-84 plus CE, but a lot of what I say will be similar for others. Now, I've got three examples because if we remember our algebra, there are basically three cases that we are generally interested in with these types of asymptotes. Now, the first thing I will say is this is not going to directly graph these types of asymptotes. I'm going to have to use the graph and interpret and use my knowledge of algebra to help me. Let's start with our first graph then. Now, these are all fractions, so to help me graph, I'm going to hit alpha y equals to pull up my menu here, and let's pick that first option of n over d. So let's type in x plus 2 on top, and x subtract 1 on bottom. Again, make sure you hit subtraction and not that negative sign. As a reminder, if you don't have that ability to type in the fraction, so if you've got an older calculator, you can type it in with division, but make sure you put parentheses around the entire numerator and then parentheses around the entire denominator. So let's go ahead and graph that. Now, I have another video about how to find vertical asymptotes, and some of what I say here in this video will be similar. So we know there is a horizontal asymptote, and it's somewhere in here, because as we can see, there is a break in here. On the left side, I'm going that way. On the right side, I'm going this way, but it does look like there is some sort of line in between that both of those are following, which is what an asymptote is. And I can at least use this to say approximately what it might be. It looks like it might be about 1. But the calculator does not graph that. The calculator does not give it to me exactly. Now, this one does have a horizontal asymptote. I'm going to write just HA for short. And if we know from algebra, it is actually y equals 1. So I can kind of approximate that with my graph. But what I tell students to do is the main way I'm going to use the calculator is to check that. So I'm going to go back to my graph, my y equals. Now I'm going to keep that graph as y1, and in y2, let's go ahead and graph in that horizontal asymptote. So I said it was just y equals 1, so let's type that in. So I've still got my rational function here in blue, and my horizontal asymptote is now this red line. Now again, what does an asymptote mean graphically? It means my function's getting closer, 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 without touching it or crossing it. So I need to know that that's what an asymptote is supposed to look like, so that I can hopefully look at that and say, yeah, that looks like what an asymptote is supposed to look like. Let's say I make a mistake. And for this one, instead of saying it's 1, let's say I think the asymptote is 0. Oops, let's clear that out and put it in the previous one. There we go. Let's say I think it's 0. That's actually what I'm going to get for the second one. Let's say I think it's that one. Let's try graphing again. So again, I've got my main function there in blue. I always want to compare this to my original. And now I'm getting that red line along my x-axis, because that's 0. Well, that doesn't really look like what an asymptote's supposed to look. Maybe I can convince myself on the right-hand side, but it really doesn't look like it on the left. I went right over it, and then it's a fair bit above it. It doesn't seem to be getting closer. It seems to be getting further away. So, again, the calculator will not tell me that asymptote directly. I am using both of those graphs together and looking at that to say, does that look like what I think this asymptote should look like? So let's try my next function. Let's clear both of these out. And now let's type in 1 over x. And I'm just going to type that in as 1 divided by x because I'm lazy. And let's hit graph. Now again, it doesn't tell me it exactly, but looking at that, I would say that looks pretty much like the x-axis. As it turns out, my horizontal asymptote for this one is indeed y equals 0. Now, I don't usually bother to graph that as a separate line, because that line is just going to be on the x-axis, which I can already see. But yeah, if I look at that, that does look like we're getting closer, 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 closer to that asymptote on both the left and the right hand sides. So again, in that case, I usually just use the axis, which is already there. Now my final case is the trickiest case, because this is the case where I will have an oblique asymptote. Now let's go ahead and start by graphing that function. So let's hit y, or alpha, y equals to get my menu, select 1, and I've got x squared plus 2 on top, and x subtract 1 on the bottom. As always, check to make sure I've typed it in correctly, and then let's hit graph so I can see what that looks like. Now, horizontal asymptote, again, we call it that because it is a horizontal line. It is a flat line. Oblique means slant. So if I draw a straight flat line horizontally, this does not seem to be getting closer to it. I am going to have to draw some sort of diagonal line, at which point I will hopefully see that same phenomenon of getting closer, 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 closer. Now, just like with the horizontals, my calculator is not going to tell me that exactly, and because it is a slanted line, it's a lot harder to approximate. Realistically, you're not probably going to be able to use the calculator to just solve that. So instead, I am using my calculator to check this. So I went by hand and said that my oblique asymptote should be that linear function y equals x plus 2. I am not going to go over how to find that in this video by hand. But I can use the calculator to check, just as I did the previous ones. So let's go to y equals, let's leave that function up there, and then let's type this in as a separate line. So let's type in x plus 2, and again, that's going to show up in red. Well, that doesn't quite look correct. Oh, that's because I did the wrong one. Well, that's a good example of what it doesn't look like. Yeah, I've crossed it. That does not seem to be getting closer. That definitely didn't work. The correct answer, if I add correctly, is actually x plus 1. So let's go back in here and let's change that. So let's change this second one to just x plus 1, and let's try this again. We'll pretend I did that one deliberately so that you can see what it looks like if I get it wrong. There we go. Now, hopefully that looks a lot more convincing than my previous one did, because as I look at both the left and right hand sides, I can hopefully see that it is indeed getting closer, 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 which is what I know an asymptote should look like. One note of caution, particularly for these obliques, is sometimes if they're large, you might not be able to see both pieces. You might be able to really just see either the left or the right hand piece, or see the asymptote in relation. So you might have to adjust your window, particularly with these that have the obliques, because they are a little bit harder to see. But if we do get the window such that I can see both pieces, then once I get that graph, I should still be able to look at that and say, yes, that is getting closer, 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 as I expect it to. That is what an asymptote is supposed to look like. So again, I'm using the calculator more to check my algebra work than I am to actually finding these with the calculator.